In this lesson, you will learn what the CPU does, the main parts inside it, the purpose of registers, how von Neumann architecture works, and how the system buses connect the computer. We will also follow a simple example to see how one instruction is processed. The Central Processing Unit. The CPU is a part of the computer that processes instructions and data. It is also called the processor or microprocessor. It is found in computers, tablets, and smartphones. The CPU repeatedly fetches an instruction, decodes it, and then executes it. Components of the CPU. The CPU contains four main parts. The control unit manages the process. The arithmetic and logic unit carries out calculations and logical operations. Registers store small amounts of data very quickly. Buses carry data, addresses, and control signals. Control unit. The control unit reads instructions from memory and works out what each instruction means. It then sends control signals to the correct parts of the computer. It also makes sure that each operation happens in the correct order and at the correct time. Arithmetic and logic unit. The ALU carries out arithmetic operations such as addition and subtraction. It also performs logical operations such as AND, OR, and NOT. For example, when the computer calculates 7 plus 5, the ALU produces the answer 12. Registers. Registers are very small and very fast storage locations inside the CPU. They hold data, instructions, and addresses that the CPU needs immediately. Registers are faster than RAM, but they can only store a small amount of information. PC, MAR, and MDR. The program counter stores the address of the next instruction. The memory address register stores the address currently being accessed. The memory data register stores the data or instruction being transferred to or from memory. CIR, ACC, and system clock. The current instruction register stores the instruction being decoded and executed. The accumulator stores temporary values and results from the ALU. The system clock produces regular timing signals, so every part of the CPU works in step. Von Neumann architecture. Von Neumann architecture uses the stored program concept. This means that both instructions and data are stored in the same memory. The CPU accesses memory directly and processes instructions in sequence, one after another. Von Neumann architecture diagram. This diagram shows the main components inside the CPU. The control unit, ALU, registers, and system clock work together. The address bus carries addresses, the data bus carries data, and the control bus carries control signals. System buses and memory. The system bus connects the CPU, memory, and input or output devices. The address bus carries the location of data. The data bus carries the actual data. The control bus carries signals that control reading, writing, and timing. Fetch, decode, and execute. First, the CPU fetches the next instruction from memory. The program counter gives the address and the instruction is loaded into the current instruction register. Next, the control unit decodes it. The CPU then executes the instruction and prepares for the next one. Worked example. Imagine the instruction is to add 8 and 5. The instruction is fetched from memory and stored in the current instruction register. The control unit decodes it. The ALU adds the two numbers and produces 13. The result can then be stored in the accumulator. Quick review. Which part performs calculations? The ALU. Which register stores the address of the next instruction? The program counter. What does the address bus carry? It carries the address of a memory location. Summary. The CPU fetches, decodes, and executes instructions. Its main parts are the control unit, ALU, registers, and buses. Von Neumann architecture stores programs and data in memory. The address, data, and control buses connect the CPU with the rest of the computer. Thank you for watching. Like and subscribe for more IGCSE Computer Science revision. Visit www.tuitionharbour.com or email hello@tuitionharbour.co.uk.